Okay, my outstanding friends, today is going to be a new day. Mudfossil University School is starting. And we're going to start with talking about rocks, and I am going to show you some new evidence about rocks being preserved in a process I call mud fossilization. I have studied it for many years now, at least 12 very serious years, and I fully understand the process by how these body parts stabilize. And I mean, this is a piece of meat. I'm going to show you all this stuff in the microscope, but what they are going to be talking about is mainstream geology. They say there's 3 types of rocks, and then they go into all the different names that they have for them. And it's igneous, sedimentary, metamorphic, and then all the different basalt and pumice and pegamite and banded iron and chalk and sandstone and gneiss and all these marbles and so forth. Now, we're going to go through all this, but we're going to start with the very basics. And I was on the fence of whether to just shock you right up start, but or take it slow, but I'm going to go with the shocker. Here goes. Hello, my very good friends. I'm happy to announce that we're getting started with the school, and this is going to be the introduction to mud fossils and geology and so forth. And you're going to see a little bit of a different slant on geology. Well, quite a different slant. So let's get started. Okay, my friends, I said I'm going to go for the shocker. Well, everything that I can find is made from body parts, and some of the body parts are absolutely stunningly enormous. That is a hair follicle, and so is this. That right there is where the muscle attaches, the erector muscle. This right here is the sebaceous gland. That's the shaft of the hair. Down here is the vein and artery. There is absolutely, everything is there exactly 100%. And it's approximately 500 times bigger than a human. And I have things, all kinds of things that are absolutely, just absolutely stunningly enormous. But this makes it very simple to see. Very obviously, this is a hair follicle. Now, if this is a hair follicle and it's 500 times as big as mine, let's say I was even 5 feet tall, which I'm not. I'm a 5'10", let's say, but let's go 5 feet times 500. That's 2,500 feet. That's a half a mile tall. We're talking about things that Enoch wrote about, things that were laughed at. And this here, right, you see up here? I don't know if you can see that in the microscope, in the camera. Yeah, I guess you can. That's literally a piece of meat. Let me turn this off and you can see it better. That's literally a piece of meat that has turned into stone. And that is the fascia on the top there, which is the membrane that held it in place, surrounds it. All right? So I have support for everything I'm saying. That's it. That's literally a piece of meat. You see underneath? It's all well marbled, and I mean, the thing looks like it was eaten pretty good, whatever it was. Now, all of these things have appeared to have died in a great flood. They're all basically, some of them are torn up, some of them aren't. They separated along these fascia planes, which are the membranes. And that's what creates feldspar. Feldspar is what coats 99% of my mud fossils. Okay, my mud fossil friends, this starts basically the beginning of the new school, and we're just going to go into the earth, geology basically, and we're going to start with the types of rocks, and then we're going to go into the formations, and very shortly I'm going to go into Petra and the Grand Canyon and all of these anomalies that they see, and they try to make some reason for these different formations. And this is how they categorize them. There's 3 different. There's igneous, sedimentary, and metamorphic. Igneous is formed from melted rock deep inside the earth. That's what they say. I disagree with everything they say, so we're going to find out what I say. Now, sedimentary is just like layers of of silt and so forth. And I also disagree with that. There are sedimentary rocks, absolutely, but they're not all sedimentary. When they see layers like that, that is not sedimentary. Now, then you go to metamorphic, formed from other rocks or changed by heat and pressure underground. And they see these patterns and they say that's the only way it could have happened is heat and pressure melted, causing these formations. Now, I am going to present an alternative view, and it's biological, it's not geological. It ends up being geology, but it started as biology. Okay, so like I said, I know this is a bit of a shocker, but it is what it is. Now, this, I also do the electron flood theory, physics, space, chemistry, the geology, biology, the immune system, all of that stuff, anatomy. So, because you have to do it all. And I'm going to show you right now, all of this stuff is anatomical. I showed you this, which is the hair follicle. That's a gigantic creature. Nobody expects this. And every one of these things died flat on one side, which means it was from the flood. You see how flat that is? That's a lung. It's been DNA tested, CAT scanned, and everything else. And that spot right there was where the heart was. This is a left human lung. All of that stuff was done to it. And this is the fascia that coats it. And it's also called feldspar, just as this is called feldspar. And guess what this is? I believe this is a liver, and I believe that little spot right there is where the gallbladder is. I'm going to show you the anatomical. And I'm going to put a little water on there, and you can see how the organs actually function. You see how flat that is? Same thing. They all died in a flood. This is a species. Whoops, let me get this book out of the way. But again, we're going to have all new books. We have to have new books. We have to have new thinking and new discussion. And these are the no-toes, which the toes are built in, and they have springs inside instead of bones. And we have a lot of these. And that's where the regular tibia would have come down, the big bone, and the fibula sits on the side, and they fall right off because they're only held in by a couple of ligaments. Now, this is a heart. That's a heart too. It's an opal heart. Well, how did this heart turn into an opal heart? And what about this? Because this is also a heart. That's a heart too. Only this one only has silicon coming in. The one I'm going to show you now has all the transition metals, which are blood. This died, and all of the transition metals, instead of here flushing through and creating silicates, that's the ventricle wall. That's the aorta up there. This is the same as this. Only it flushed out all of these colored metals. Those are the transition metals. Now, there's a little bit of blood left over in this area. Now that's that's a blood opal. All opals are made from organic molecules, which primarily is blood. The more colored they are, the more into your transition metals they are. This is a heart too. And it was, again, just like this one, found in the same region where everything leached out of it, and it turned into what they call a water opal. It's just like that. And here's what it looks like inside. It's the exact same thing. It's just that all this flushed out, and then they break off. Sometimes they break right off here, clean, and all that plumbing goes, and then you get that jello bag down the bottom. Now this kept all that plumbing up at the top, but sometimes they fracture right off there, and you get the ball at the bottom, like right there it would have fractured. All right, so again, everything's flat on one side. The organs sometimes they don't get flat, but the lungs, the guy must have just died flat. Now he might have died like this, upside down, this way, over this way. I don't know. This guy died flat. That's the way I'm taking it. You see it? And that's that little flap on the bottom of the lung. It's saturated with blood, literally saturated with blood. And that's where I took the blood from, sent it off to get it tested. And it came back Homo sapien, mitochondrial DNA. There was two regions that they looked for just to prove that it was human. And this came from deep inside. I didn't scrub it off the surface. You take a little pin drill, you drill right in there, and you come out with the red blood. I checked this out. I think this is a liver. And I think that little spot right there is the gallbladder. See, the gallbladder has a little protrusion, and that little dot right there is at the bottom, I think, of the liver. Now, I just put a little water on there. I'm going to put it in a microscope, but you can see there's different layers of biology inside, and there's blood coming in and out. You see the red and the black? And this, I'm going to have the same thing in this. And I believe that is where the gallbladder was. So we're going to take a look at it. But again, it's flat as a pancake. I'm telling you, these are all creatures that died in the Great Flood. It was all written about. Velikovsky had all the accounts of it. Not hard to understand once you really pay attention. Even I showed you, well, maybe I didn't. This is my pet goose, Caesar Augustus. All right, there's his feathers. And he has the same collagen fibers as lungs do, as livers do, as feet do, as everything does. It's called aluminum silicates. And the reason they're aluminum silicates, again, you have to understand chemistry. Phospholipids create membranes. And what are the membranes made out of? Phospho, which means phosphorus, lipids means fats, fatty little molecules, and these phosphorus bonds, that when they get heated up, they break, and they turn into aluminum silicates. So this would have been phospholipids originally. All your fascia, which means all your membranes, 100% of your membranes, 100% are made of phospholipids. And when they get heated up, the phosphorus breaks down to aluminum silicates, and 100% of all fascia, of all feldspar, is aluminum silicates. 100%. I'll show you right now. Feldspar is what I'm talking about. This is all feldspar. All you have to do is read this. Feldspar, which is all of these coatings, is a name given to a group of naturally occurring aluminum silicate minerals, feldspars, containing a varying amount of potassium, sodium, calcium, and or lithium. All of that is right below here. Calcium, potassium, and so forth, in your phospholipids. All right, so this is the breakdown of the membranes into aluminum silicates, first of all, containing some of these other varying metals and minerals. Now, these are the ones that are transition metals. These are the real colored ones. These transfer through your body, carrying everything. They carry what they call ligands, are little attachments that carry on the metal, and it goes through and it snaps over to here and over there and over there and feeds your body with oxygen and glucose and all the other things. So these are very, very important. And if a body dies in the right situation and that blood pools in there and there's nowhere for it to go, and it also mixes with a lot of silicates, you end up with these extremely beautifully colored silicates, which is that heart, which are opals, like, actually. Okay, what you're going to need to do is to go to Mudfossil University on YouTube. Just search through there. I got a ton of stuff. We're going to start to separate it out into playlists and then have forums and question and answers on all of that stuff. However, in the meantime, I want you to know that rocks, all these different types of rocks, it's just not correct. It depends on the conditions they were in. And I'm going to show you lungs that's changed to all of these different things that are still lungs. All right, I'm going to show you, and anything will change into anything in a rock type nature if it's in the conditions where, and I'll explain the conditions of each one of them as I go. But this is the American Museum of Natural History. They're talking about if rocks could talk. Well, they can. And here they're going to be talking right now. Okay, my friends, I have a whole variety of lungs laid out. This is right down the alveoli of a lung that is starting to create crystals. Crystals will form inside of lungs in the correct conditions. Now, these are two different types of, well, they're two lungs, and I don't know what they're from. I know this one's human because I had a DNA tested, and that one exuded some blood. But they are both lungs. One of them is completely converted to quartz, and one of them is basically has a lot of tissue left inside of it. And I also, what else do I have here? I want to show you the transition metals. I don't know if I talked about those yet, but we will. And they carry everything through your body. And those are the things that we found in that heart, opal heart, because they leach out of the blood. They're part of the blood. They're part of the blood. If you don't have them in your blood, you're in trouble. Especially the ferrous oxides, iron oxides. There's a ton of it. That's why you're red and blue blood. I don't know why you have this colors, but they're red and blue in your body, and then they're still red for the hemoglobin, and the other one, the artery blood, and the other one is the vein blood. It turns black. You can see right up here. You see the black stuff, and then there's the red stuff. The red stuff is what ends up creating the crystals because it flows. The black stuff hardens up hard. All right, check this out. This is that liver. It's broken flat across. There's the red spot. I believe that's the black, which is the vein and the artery. And that, I believe, is the lymph section. And this is the core of this body part right there. That's what we were just looking at in the microscope. And again, flat as a pancake. They're all flat as possibly can be. Now, this is a lung. All right, and they died flat again, and that's the big entrance in the back. They all have a big entrance in the back. See this here? Same thing as this one. A big hole in there. This one filled up with silicates, but the rest converted into stone, pretty much feldspar, I believe. Now, this one just completely evacuated everything, all the blood, and it never filled back in. But this is red blood. I'll show this in a microscope in a second. I think I might have already showed it, and I showed a blood vessel that was starting to convert into a crystal. But it won't do any more because it's not in that silicate-rich. But they grow. They crystallize and grow. This also is a lung. You see, that's that big flappy spot and a big hole in the back. And it was a lung. This, like I say, that was DNA tested and CAT scan and everything else. And this is the lobes where the lung is. This is the flap that it overhangs and attaches right at that very end to secure the lung in your body so it can move and do this and that, but it can't be ripped out of the body. Except until you get into one of these hot water floods. And that's what happened. It was a hot water flood really just boiled all the flesh and stuff away as much as it could. And then it got down to these membranes. And then the membranes turned into aluminum silicates. As I told you, the phospholipids converted into aluminum silicates, which is like a rubber bag. I mean, these are like rubber bags. Every one of them has the same sort of thing. You know, occasionally you get them like this, and occasionally you get them like this. Hold on. Those are the transition metals. I think we went over that. Maybe not. Maybe we did. But sometimes this lung here has the exact same inside as this lung here, but this lung doesn't have any outside. The outside's gone. So we're down into the alveoli, and the alveoli filled up with silicates where it was probably laying this way, and the red blood ran down and pooled here and had nowhere to go. So when it came out of the ground, the blood just leaked out. And here's that flap right here. You see that flap? That's an interstitium. This is brand new organ they found. I'm not kidding you. And what it does is it converts from one part of the body to the next here. And in my piece of meat here, I can show the actual two little attachments. I should show you that because it's very cool. This is another interstitial flap. That's an interstitial flap. They all have them. That's what this is right here. It brings the blood into the next organ, because this is a completely body-wide organ system. It's the biggest organ in the body now, they say. They just discovered this a few years ago. I've seen it for years because of my mud fossil research. It's all here, and I talked to a guy about it years ago. And but here it is, just a 2018 meet your interstitium, newfound organ, and that's all of this stuff. How it turns into this feldspar. This is the layer right here, and this is the layer because it has this aluminum silicates in there, or well, phospholipids. It's a membrane. You know, it's not body tissue. It's body tissue, but it's a membrane which separates one layer from another. That's what they do. And everywhere there was a layer and it got boiled in the right way and converted, and then it died flat, and then it just turned into stone in the right places. I'm not saying this is everywhere, but anywhere where you can find individual rocks and you see feldspar. Feldspar is collagens converted into stone. I'm almost certain that virtually all of it is. Body tissues at any rate. All right, everybody knows iron meteorites come from space. This is an iron meteorite. It's a little tiny one, but it is also a lung. And because it was saturated with blood, it turned into iron. Blood is iron oxides. And it's an iron lung. And when I show you this in the microscope, you'll be able to see all the blood vessels. And it's heavy for a little bugger. Now, this one here is a guy's whole body. This is his chest. No, I'm sorry. This is his chest right here. And it all ran off and exposed his lung. There would have been ribs. They're gone. All right. And this, I believe, is his back. And these are the bones of his back. It's one or the other. He either died on his face or on his back. But this is one side or the other. And this is the outside of the body. And this is the inside where the lung was. These are the lobes of the lung inside there. And this was the casing of either the backbones and the ribs, one or the other. But this one's completely eroded away down to you see these the same as this. All right, the other side just has the bones. You can still see a lot of the bones. See, so it died that way. Okay, my friends, I have to get ready for my discussion with Jim Bolin. He was a senior environmental scientist until just recently with the Corps of Army Engineers. And he was a field guy. He went out and certified bridges and dams, and they were also looking a lot into water contamination and so forth. And they really couldn't figure out why fluids were going in the places they were going, why it would come down here and end up over here. And it's because of the plumbing in the earth, literally plumbing. Now, we're going to talk about this. He's on board. He understands now. He says, we just didn't understand. You know, they take this right here. They say this is millions of years in one picture. Like every one of these was a layer laid down. That's not the way it is. That, my friend, right there is a tendon core. You say, what is a tendon core? It's where the main part of the tendon attaches to a bone or wherever, but that little dot there and this big white slab is the main engagement of the tendon. Now, these are little slabs that can slide on each other so the tendon can move this way and that way and still stay anchored in the middle. Here would have been a bone probably, and here would have been the abrupt transition going into muscle. And here's what it looks like in one I have here in my shop. Where is it? Right here. All right, there's that little dot, one side or the other, I'm not sure. But that's the center of the tendon. I believe that's over here. And then you have all this stuff coming down the sides, up and bottom. Then you have a whole ton of blood that flushes down for the muscle. But from here, the muscle just erodes away. And here, the same thing, the bone, especially in the ocean. Here is the whole thing. And from here to here is what's sticking up in the ocean. And that's the tendon. It locks it into a bone, and there's just a tiny little bit. You see the dot right there? There's that circle I told you about. You see it? That's the circle. It's basically right there in that bone. I mean, in that tendon. And that's exactly the same circle you see on the one sticking up in the ocean. You see it right there? Same thing. But ocean water erodes bone and it erodes muscle. Very easy. Tendon, whole different story. Tendons are what Giant's Causeway is made of. Devil's Tower. They are tough, and still tougher than that. Now, you've seen the things I'm talking about are just gigantic. The Earth was a creature just like they said. As far as I can determine, nothing but creatures. And this is sarcomeres. And of course, these are microscopic. And these are sarcomeres pulled together. They're muscle. And these are sarcomeres relaxed. When they pull together, the black and the white comes right together. They're just glued in blocks. You want to see what they look like in stones? Here's what they look like in stone. Right there. There's the sarcomeres. They're glued together here, and this is where they pull together. This is just a relaxed. Now, what is all this red stuff? That's actually blood. You have to have a ton of blood to supply muscles with all the oxygen they need and all the nutrients they need to really, really work. These things are working hard. This is what ran out over there in Turkey, and then the whole hills collapsed. Make sure you see these blocks. Here's Turkey. I tried to alert them that, you know, this is what happened. Here it is right here. These are those blocks. And this is red blood coming out of here. Here's red blood coming out over here. That's and down there was other shots I had. I don't have it here now, but there was other shots where you could go way down inside here and see the whole bottom just ran out with red blood under, and then it just caved in, just like it would if this right here all washed out of here, going down the hill, whatever direction it was at, because that was on a hill, and that ran out. So now all that stuff is gone, and you have a lot of weight on it. It's just going to collapse, and it collapsed in the whole valley there. It wasn't just one little crack. So there must have been big voids in here, and then they just let go. These are the same. Those are muscle sarcomeres, and it ran down this way, all coming out from underneath. That's the only thing I can determine. All right, so you understand we're talking giants, and some of my giants are DNA tested. I have two of them DNA tested, and one of them a fingertip CAT scan. Hold on, I get the fingertip. It's right there. That little, it's kind of small compared to the other one. The other one's 3 feet long. That's a fingertip. It's CAT scan. You can see the bone. You can see the it was all one piece before. You can see the artery and the vein coming out the back. You can see where the fingernail was here. It's eroded a little bit, but it's still exactly what a fingertip should look like, where the apical tuft is and all that. And this was also DNA tested, and it is human. And I have the hand that goes with it, the whole palm. I should show you that. Hold on. All right, this is where you get your best blood out of them. Thumbs are just saturated with blood, but they all are. There's a vein, artery comes down, the vein comes back. There's 2 on the side, 2 on the tips, and 2 on here. Veins transfer over into the arteries transfer over into the veins, and that's what you see right here. This is a fingertip. All right, that right there is the artery side, which doesn't take on a lot of color. The red blood basically runs out. This is the vein side. That takes on the black. From this little tiny hole, that's the vein. This is the actual tendon. And that is also the actual tendon. You see it? You see this core in the center of it? And that, like right there, that little dot is where the blood was. And this is the bone. And I believe it's a thumb because it's got an offset bone. Now, that was from the back, surface scan. This is from the top. That's where the fingernail was. And they have these cuts on the side, which are where the tendons locked in. This is from the back. You can see, you can just barely see the bone. You see it? This is what's called nucleophilic invasion and substitution. Whatever was here eventually gets replaced, totally replaced. Now, the exception is membranes, because those are the separators anyway. So if there's a really good dense membrane and it's long enough, it will show up. But if it's just like this, you're not going to see it. You just go right, it's not going to be visible. So that's why it's very, very hard to make out any real detail. It's not like an x-ray. But the surface scans are fabulous. I mean, look at that. See the bone, no problem. You can see the, anyway. And this is the other one I had. I showed you the 7-inch one. This one here is 3 feet long from back. That's the fingernail. All right, this right here is there's a little pad in between each one of your bones that rocks on it, which is like a little separator. Vein and artery. I broke this piece off so I could get in to get the blood, because you can't get blood out of this style of the stone. This stone was just as hard can possibly be. And I just gave it a whack right here. I can't remember, it was a long time ago, but I think I just used a hammer, banged once, and it popped off. Because I'm pretty brutal the way I do things. And here's what popped off. There it is. It's the fingerprints. That's a fingerprint ridge. Same as one of these. There's the sweat pores. See the sweat pores? And they came right off just like this. And you can't get blood out of it. There's no way in the world you get blood out of that. It's just like this. It's like a mat of nothing. And that popped off all in one piece. And it's probably about that thick. So that's the thickness of that guy's skin, which is on his fingertips. And the sweat pores and everything are showing up here. That was also DNA tested as human. And that one had excellent quality DNA. And so did the lung. And this one had good quality DNA, but it wasn't as dense, because this was more in mud. All right, this is a true mud fossil. The other ones really preserved exceptionally well, encased. So they were a little more like this thing here. I mean, it just virtually was, you could transplant that thing. I'm telling you, it's just flawless, absolutely flawless. There's a red blood just at the tip of it. You know, if it wasn't hard, an autopsy guy would look at that and say, yep, that's a lung.